Oh, hey guys, sorry, didn't see you there. Okay, fine, it's time to get serious. We need to talk about Chapter 9 just to stay on track through the semester. Chapter 8 and 9 are both about bringing all the puzzle pieces together, so it's a lot of different topics within TCP/IP, the entire suite of protocols. So I'm going to go through a lot today, and then Jim Musselman is going to wrap it up with you on Thursday. So here we go. Let's recap one important concept to begin with, that the function of routers and how they separate the outside from the inside of your network. Routers are the most intelligent device that you can put on the network, and they solve a multitude of problems, not the least of which is just getting messages out to the internet. They also do some very cool things with IP addresses, one of which is going to be network address translation, which is the first topic. Also notice that you can change the IP address scheme. So if you get into a situation like we talked in class about where you acquire another company and they are using a different IP address scheme than yours, you can slap a band-aid on there in the sense of putting a router in there to do some IP address translation, because routers can understand a variety of different ranges of IP addresses. They're very configurable. Even IP address ranges with completely different subnet masks, which is cool. So remember that routers have an inside and an outside. Notice also on this diagram that this is kind of a shorthand. You can't plug in servers into a router. There's got to be a switch in here that's just kind of implied on the local area network. The diagram is just there to show how a public IP address gets translated into many local, in this case a Class C 192 addresses. Network address translation is an important concept. The reason I say it's important is because you first ran across it in Chapter 1, and then we keep bouncing back to it in subsequent chapters, and here's where we need to get into the specifics of what it does. The device that's going to be running the network address translation protocol might be your firewall, and it might be your router. For the purposes of our discussion, we're going to say it's your router, but like I said, it could be your firewall. It depends on the complexity of your network. The book says that it sends a false external source IP address and port number that are different from your legitimate internal IP addresses. I don't like that word false, because it's not a false address, it's a legitimate address. It's just converting a public IP into a private IP address. And we said in class that there are two reasons for NAT. One is, I think it still very much serves a security purpose. Anytime you change the IP address scheme, that's one more thing that hackers have to navigate to get onto your network. And then, of course, the other reason is to give you more internal IP addresses. So, for example, your ISP, Charter, Time Warner, AT&T are not going to give you thousands of public IP addresses. They could sell them to you, but they're very expensive and you don't need them. Really, you only need, for a small business, one public IP address, and for a medium-sized business, a handful. Maybe for a large company, you'd need several dozen public IP addresses, and I'll show you how to calculate that in a second here. NAT is doing something very specific. It's translating IP addresses. It's creating a map, if you will, that if something needs to go from this internal IP address to this external, out to the internet, it's going to go out using this IP address that's been assigned to you for the public side of here we're saying it's a firewall, for the public interface, because the internet needs to see, all the routers on the internet need to see a public IP address as the source address, because they don't know where this is. Routers on the internet know where this is. Also notice that we're doing a little flim-flammery here. We're not just changing the IP address, we're also changing the port number. Ooh. This is actually a separate process called port address translation, PAT. You may have run into this again on your Xbox. A lot of gamers have to do port address translation, where they have to change how the port number is going in and out. But for NAT, we can kind of combine these two concepts to say we're changing both. We have a translation table. This internal IP address and port number gets translated to this external IP address and port number. The point of this diagram is just to show if you had a copy of Wireshark running on a network segment right outside your firewall, you would see packets coming from the public IP address, but you wouldn't see the original private IP address. So that's why I say it's another layer of security. I said you can get away with sharing one public IP address, but that's not quite true because public IP addresses are expensive. You have to pay for them. Keep in mind when we discussed ports earlier at layer 4 that there are 65,000 or so possible ports, all assigned to specific software applications. But at the top of that list, there were all of the TCP/IP ports, and then the registered ports, and then at the top of the list, there were about 4,000 ephemeral ports. Ephemeral is just another word for dynamic or temporary. They're available ports to be used for whatever. Well, we need available ports for whatever for doing port address translation. So if there's about 4,000 available, that means each public IP address that's assigned to us, we could map out 4,000 different simultaneous connections. Now, keep in mind that doesn't mean that 4,000 clients can be talking on the internet through one public IP address, because each client actually has multiple connections, and you know this to be true if you look at your pull up your task manager, look at your processes. Chrome alone is taking up, depending on how many tabs you have open, 10, 12, 20 simultaneous connections. Dropbox is taking up a connection. So it's not a one-to-one relationship, but if you were to say, well, every client is going to use no more than 50 connections, probably less than that, simultaneously, you can start to figure out, exactly how many public IP addresses you're going to need to purchase. But it involves doing a little math and a little guesswork and a little trial and error. If you want to see what I mean about the number of simultaneous connections, the netstat command at the command prompt can show you exactly how many connections you have on your PC, your laptop right now. So if you run netstat-n and netstat-b, we'll show you two different views. So play around with those just to get a sense of how many connections you have to the internet right now. In order for network address translation to work, you've got to use one of the assigned private IP address ranges that we talked about in class. Class A is a 10net, Class B the 172 range, Class C the 192 range. Also, I should add the subnet mask here because you can't use, for example, a 192 net with a /8 subnet mask. That's not a legitimate private IP address range, and it's going to conflict with something on the internet. Don't believe me? Try it. Nice thing about NAT, once you enable it, it just automatically does its thing. You have to configure, here's the range of IP addresses you can use, and then it takes over from there. So once you enable it, you never have to touch it again. Except sometimes you do have to touch it. I have seen in the real world times where the NAT pool of IP addresses gets used up, and for some reason it won't let go of those connections, and the only way to force it to let go of connections that aren't in use anymore, in order to free those up for new connections, you have to flush it. It's called flushing your NAT pool. That's why I have the flushing picture here. It should do this automatically. Sometimes you have to help it. So if people can't get to the internet, you might have to either give a flush command at the command prompt, or, as with all things, just reboot it. Just reboot your firewall. People will be down for a couple of seconds, but then they'll be able to get back out. Your NAT pool can become depleted if you didn't get enough public IP addresses. So this may be a symptom that you need more public IP addresses in order to support more simultaneous connections. Okay, that was NAT. Now we need to go back to DHCP and DNS, which are also part of the TCP/IP stack, but we need to do a little deeper dive into what they're doing. We always talk about them together, just in any TCP/IP class, seminar, training class you go through. They're always talked about together. They do different things, but practically speaking, they almost always, the server services are running on the same box, and that box is typically an Active Directory box or your LDAP box in a Linux environment. But for most of you, this is going to be an Active Directory environment, a Microsoft environment, and the DHCP server service, the DNS server service are running on your Active Directory server. There are times when you want to have a decentralized environment. So for example, at Corning, at our manufacturing facilities, we didn't want the manufacturing sites having to resolve all their DNS queries by going back to the corporate location. Just in case the network line went down, then the manufacturing lines wouldn't be able to run. So we did have a distributed environment where there was a dedicated DHCP DNS server, which is very lightweight and just doesn't take many resources at all. So it's a small server. We had one at every location as a backup to serve up DHCP and DNS services locally, just in case the corporate site went offline. Let's be really precise about what we're talking about here. There's the DHCP server service that obviously runs on a server, and then there's the DHCP client service that runs on a client or PC. And it's the client service that automatically runs when you boot your PC and requests an IP address for that machine. If you look at the services, all the possible services, like go into Windows, your control panel, look at services, you may see, depending on the version of the operating system, you may see a DHCP server service. Don't get cocky and say, oh, well, I want to run DHCP, so let me enable that service. No. That would turn your PC into a DHCP server and would cause havoc because people would be other machines would be sending you requests for IP addresses. You'd be running the server service, so it'd be trying to respond, but it wouldn't know what IP address to give, so people would not be able to get a legitimate IP address, and they wouldn't be able to get on the network. So leave that alone. Really, when you're creating a PC image, you should just get rid of this entirely. There's no need for it to be in a client operating system at all. But of course, Linux is a client operating system and simultaneously a server operating system. So this is automatically going to be part of every Linux installation as well. So just watch out for that. Just to review the steps, the DHCP goes through, your client boots up, it sends a request. The way it sends this request is through a broadcast, and now you know what a broadcast is. It's a message that is sent to 255.255.255.255, i.e. everywhere. So it broadcasts it everywhere on the network. Hey, is there a DHCP server anywhere on the network? And if you have multiples, the closest one or the one assigned to your range will respond and negotiate a little transaction with your PC. So it's going to assign it an IP address, but it's going to do some other things. DHCP gives your PC 5 pieces of information. 5 test-worthy pieces of information. The first is obviously your IP address. The second, it gives you your subnet mask. The second part of the Holy Trinity. Third, it gives you your gateway address, which is the internal interface of your closest router, the third part of the Holy Trinity. Gives you those 3 pieces of information so you know routing can take place now. In addition, it tells you the address of your DNS server, and it gives you your lease time, which is something that the network administrator has set up. 2 weeks is typical. A month is probably too long. A day or two is probably too short. A couple of weeks is typical. And by the way that it renews the lease is the way the protocol is set up is halfway into the lease, your PC will send a renewal request to the DHCP server, and the DHCP server will say, yes, you can have it for another 2 weeks. So it keeps renewing and keeps renewing. If it fails to renew, that's when it has to request a brand new address. So an example would be, let's say somebody goes to Hawaii on vacation and they put their laptop to sleep, and which doesn't free up their IP address, and then they come back into the office, let's say 3 weeks later, and lift up the lid. The Windows thinks that it can still use this IP address, but in the meantime, of course, the lease has expired. And DHCP has more than likely, the server has more than likely assigned that IP address to somebody else. So what's going to happen to me? Well, I'm going to get an error message. and that error message says there's a duplicate IP address on the network. What do I have to do? Well, I have to reboot. Maybe the other person has to reboot as well. Or, if we know what we're doing, we just go to a command line and do what? Type in ipconfig/renew, ipconfig /release, then /renew to get a new IP address. Or just reboot. Rebooting fixes everything. So I forbid you to think of DHCP as magic. It's not magic, it's just math. 5. Even though DHCP saves us a lot of time as network administrators, there are times when you don't want to use DHCP. You want to disable it, and you want to manually assign a static, as in it's never going to change, IP address to certain devices. Those devices include servers. Should have statically assigned IP addresses. Don't let servers pick up dynamic addresses so that they go wandering around the network and you don't know where they are. Servers need to have static IP addresses. Typically printers, access points, routers, management interfaces for switches, any network device, firewalls, really need to have statically assigned IP addresses. The exception to this is at home. Your device at home is using DHCP to get a DHCP address from Charter. Now, if you were a business, you would never do that. You'd be statically assigned an IP address from Charter. So there is a difference there.